we as Teradata, we typically focus on the industrial IoT. And there's a reason for that, because industrial IoT is the new generation of solutions which are going to drive a lot of data. And a simple example is that jet engine from the flight generates basically 0.5 terabyte of data just flying over the ocean. And those data are not used by the airlines, those data are used by the engineers to tune the engine so they can work better and consume less and less fuel when they are flying over the ocean. We have expertise working with different industries like oil and gas, smart cities, utilities business, and other industrial factories like Industry 4.0 in Germany, which you can see a lot. But IoT, especially industrial version, requires us, especially in the IT and OT business, to think totally differently. First of all, we should stop saying Internet of Things, it's Internet of Systems. Because the value comes when you start bringing the systems data all together, and you teach those systems to talk to each other. Because it doesn't make sense to just look at the engine data, you have to combine this data with the fuel consumption, then with the crew setups, so we don't have those situations like sometimes happens with the airlines swapping the passengers with the pilots. Yeah? The really key element is, which you heard a lot this week, is that there's this OT world. And there's a lot of companies who talks to OT, the operation people, and there's a lot of companies which talks to the IT people. We are one of the few companies which understand both worlds, and we try to always bridge those worlds to explain that engineers on the operation side, they can help drive more value for the company, but they also need to be compliant with the IT regulations and the systems they are designing. And then there's always the question, why the platform? There's a lot of stories about moving data to the cloud, working with the solutions which are more in the cloud, which is slowly happening in the industrial IoT. But still, a lot of solutions, they have so much volumes that they require on-site presence. And this is why we are also working with Cisco to figure out what is the best offer, how we can marry those two worlds, being on-premise as also being able to shift data to the cloud, for example, to other partners. So people ask me a lot of times, what is really Teradata doing in IoT? Because when you read newspapers, what you hear a lot is the edge computing. Everybody's talking about the devices and edge. What we do as Teradata, we basically, as I was saying, bringing those different systems all together. We integrate all of this data at scale, and then we build the models which has to be pushed to the devices. Because in the OT world, sometimes SLAs are below second. We have customers doing 20 milliseconds from the action on the device to the decision on the control system. And those models to be pre-built based on the historical data, on data coming from the different systems. But you can see we have a very tight integration, and this is why we are working with Cisco to figure out how we can be able to not only take data from those edge and fog devices, but also push the analytical models back to those devices. So build translation microservices which will allow you to talk to PLCs, the SCADA systems, the industrial robots, or even to the cars. So on the high level, when we were looking at the architecture, we said, so how we can really work together? And we didn't want to have those arrows showing that there's Cisco here and there's Teradata here, so we draw this joint architecture saying this is how we are going to be integrated. And you can see on the beginning we have Cisco Edge, and there could be different families of the switches doing the edge computing, which of course is doing the security, device management, so key elements of the edge piece. But then you can see here we have the Cisco/Teradata fog node. Why we said /Teradata is because we are utilizing Cisco hardware, the industrial fog servers, to put Teradata solution on that. Because this can happen that the factory is saying, I have big volumes of the data, I need to do more local processing. I want to do feature extraction, variable reduction process. So therefore, I need to do this locally, do this compute, so we can help Cisco hardware to basically perform this action and execute back to the edge. But sometimes you want to look at the full data set. So you have customers storing 5 petabytes of the raw high-frequency data, and engineers, they want to basically build models on this data. So this is why we come into the play with our knowledge of handling the large volumes and doing the analytics at scale. Because we as Teradata, we are in the firm belief that you cannot bring data to analytics, you need to bring analytics to the data. Because it's easy to say, I'm taking 0.5 terabyte and moving this to memory, but you cannot move 1 petabyte or 5 petabytes to memory. We have technology how to execute models and mathematical functions inside database, leveraging different data types, starting from JSON to Avro, even time series. And also what is important, there are different SLAs. So in the operational world, if you look at the IoT data flow, the data typically has two distinct flows. There is what we call the aggregated snapshot view at point of time, which reports automatically to the dashboard, or then generate the action back to the PLC or SCADA. Then we have an operational near real time. This is where you are saying, maybe I should readjust the model based on my actions happening right now. And this is why we're saying this will typically happen on the fog, because this is where you need more storage and more compute. And you can see there's more and more even GPU coming in this place, because people want to do the more automated variable reduction and feature selection. Now this is more the strategic, because as an engineering team, for example, one of our customers, they know 2 weeks before the parts in the train are going to fail, because they guarantee 100% availability of their trains. And they are so committed that if they will not guarantee, and for example, let's say the New York Metro will stop, they will pay back the New York Metro of the fees, which were happening because of their trains. So this is why you need to have engineers understanding the data. And also what is very important in IoT, which is not said a lot of times, is that 80% of times it's not devices are failing, it's sensors are failing. We found a lot of use cases that it's more complex to build models to understand that temperature sensor is failing, because you can make a wrong decision if you don't understand what is really failing. So this is a very key element. So we started with integration of Teradata and EFF, the Edge Fog Fabric, which is now the Kinect. And we wanted to follow the microservice architecture of EFF. So we decided how we can bridge the Cisco operating system for the Edge and using the EFF. So basically what we've done is we developed a small microservice which will be acting as a bridge. We'll be taking data coming from the EFF and converting them to the protocols we accept when we load data to our technologies. So we designed this data service, which is basically bridging the data and then pushing this using our listener technology to our stack of the solutions, database, the file system, and other elements. So this way, you as a customer, you will see Teradata data service as one of the microservices in EFF, but you will not have to worry about the remaining piece of Teradata. We can help you basically do the seamless integration. But as I was saying, it's not a one-way interaction. I want to take this data and now build a model and push this model back to the device. So we've done the same by following the same logic. We developed a microservice using the EFF SDK, how I can convert the PML, AML, or any other language-based model into something that can be executed inside EFF. So that EFF is then pushing this back to the device and saying, maybe I need to change some settings or shut down the machine because something is going wrong. So that's how we basically work with the EFF part. So this is just to summarize the EFF integration, the Kinect. So basically what we've done is we leverage the Cisco microservice architecture. There's no our microservice architecture because we wanted to be compliant. So whatever happens with the new version of EFF, we will be compliant with their architecture, and it makes this integration easier for you to bridge basically the EFF platform together with Teradata. And as I was saying, it's not about streaming data. So this is showing the summary that we are doing the true bidirectional connection with the devices. So the second element when we started working together with Cisco was the smart cities, smart buildings. So we work with the CDP, the Connected Digital Platform, and try to figure out what is the best way to bring this enterprise analytics and STEM processing to the CDP and allow CDP developers as well as the users to leverage both technologies. So CDP, I don't know how much you know, is basically taking data from the different vendors, for example, different lighting systems, and then unifying them and exposing them as application API. So you can develop your own application, or you can see on the Expo, Cisco is showing some of those applications being pre-built for lighting system, parking system. But in reality, this is the platform which allows you to build your own applications. But it's more focused on this real-time operational monitoring, so basically acting right away on what is happening. But cities, if you look at the smart city, they are looking for more complex use cases, because they are saying, it's good to understand the parking and lighting, but I want to understand also how I can optimize the power consumption. Can I shut down some of the lighting systems based on my historical trends, how people are driving and where they are driving? So I can optimize the power consumption. I can also rebalance how different districts are using the power. So this is about bringing those systems all together and making sure that those systems talk to each other. So what we decided to do is we said, okay, so we can do the analytics. So we integrated first with the northbound by saying Cisco will expose data over the application API. We'll subscribe to this API from our Kubernetes platform, which allows us to auto-scale the containers. And we will be taking this data for analytics. So this basically data will flow this way. We'll be able to do the analytical models here, different mathematical models, expose this data, but from the model, the BI side of the data. But then we also figure out there is a next level of integration we need to think of. Because some application developers, they don't want to go to the CDP for the application development and then to Teradata systems. They would like to talk to one API. So we said, let's do the southbound integration in the sense that I can now expose Teradata as one of those almost device providers. So this way, as application developer, you can say, I want to look at the lighting solution in the real time, and at the same time, I would like to expose some of the historical trends in the single window. So I can subscribe from the CDP to two different resources on the API layer, and I will get access to both systems. So CDP from the real time and Teradata from the analytical side. And you can say this is almost the whole integration. But what we then said, there's a third layer of integration to do with CDP. Because what I explained to you was more that we bring the data, we do the analytics, but how I can now push this analytics and build models which are influencing the devices. So if I have a lighting system or parking, I can basically take this optimizing and thinking and turn this to action. So if you know this, the CDP has a policy engine. So what we basically are doing is we are developing a model here. Once the model is developed, we are packaging the model, and then we build the translation microservice, which is using the CDP policy engine to push action back to the devices. So this way, we as a data company, we don't have to think about how devices are talking, what are the protocols. We can focus on STEM and analytics, while Cisco is focusing on building those connects to different vendors and different devices for performance execution. So you can say, why CT is integrated the data? And I was giving you some examples, but as I was saying, it really doesn't make sense to just look at the lighting system. You really need to start bringing the data from different systems. Because one of the biggest problems of the cities today is there is basically underconsumption of power. And some people start to laugh by saying, oh, if I'm not using the power, that's good for the city. In reality, it's very bad for the city, because city cannot predict when next time you need the power. So they are overproducing power and floating this into the network. So they need to understand your trends, your behaviors, how you are driving, what's the capacity of the different districts, so they can start balancing the utilization of the power, so we can start shutting down some turbines which are generating the power. So this is what cities are looking. They are looking for integrated view of different elements which makes the city really smart. We cannot call city with only smart lighting system a smart city. The smart city is when you start looking at all of this data at the same time and trying to figure out how I can optimize and make my city really smart. And there are even more developments which are moving beyond the sensor data. Some cities are going into the integration of the sensor data together with the genome data of their citizens. And they call themselves no longer smart city, they call themselves smart nation, because they want to improve the lifestyle of their citizens by understanding behaviors and therefore driving a better health of the people. So just to summarize what I was saying, so from the Teradata CDP integration, we are able to bring data from CDP and do the analytics on our side. Doesn't matter what is the volumes. We are known by scaling to petabytes and beyond. We also want to act as an API for the CDP, so that application developers can develop their own applications by just subscribing to the resource-based APIs inside the CDP, so they don't have to go to two different platforms. And then, of course, as I was saying, taking data doesn't make sense unless you can generate action. So this is why we are leveraging the policy engine of CDP to convert the model into the action. So for those who don't know who is Teradata, as I was saying, we are the data company. If you are interested, we are inviting you to our booth. People ask us why we are in IoT. In reality, we were doing IoT 20 years ago, but it was not called IoT, and the robots basically were less advanced in the network connectivity. But the data principles are still applicable, doesn't matter what is the volume or frequency of the data. You still need to have a governance, you still need to have a security, you still need to understand what you are doing, and sometimes outliers are the important information. As I was saying, we know how to bring IT and OT world together. We have expertise from the consulting perspective, how to talk to the different industries, how to bring this knowledge together. We have very good engine to execute STEM, which is the scientific engineering and mathematics on the data at scale. As I was saying, not bringing them to the STEM, but we can put this analytics using different languages like R, Python inside the database. So you don't have to move data back and forward in the different solutions. And of course, we are trying to solve this integrated smart city problem. This is why we believe the partnership with Cisco and this way how we're integrating will allow us, basically both companies, to deliver end-to-end solution at scale. Because it's easy to do it for one district of the city, but the complexity starts when you start adding more and more devices and more volumes of the data. So with that, I want to thank you for the session. And as I said, if you have questions, we are invited to our booth at the end of the IoT theater. Thank you.
Thank you so much, Artur.